Okay, so it said something about the audio, so I'm just running it again. Okay, so let's go back to the VMware. All right, so I'll repeat a little bit. So as I was saying, we are going to do a problem substitution cipher just to kind of practice Python and encryption in this class. Okay, so basically this is all we've written. So we have basically a library here, import pprint, and then define encrypt and define decrypt, right? So these are the two placeholders for the functions right now. Same thing, indentation, 1, 2, 3, 4. And then I'm going to do return 0 again. Okay. So I usually like to start with like the big picture of a function, and then we can drill down into all the specifics of it. All right, so we've got the two functions, and you guys can help me out here. So what else would we do once we have the functions? What do we need? The main, right? So you want a main, and because you're used to like, in other languages to have a main, C++, for instance. So in Python, you don't really need a main, but what you can do as you're making the transition from that world into this world, the scripting world, just do that. There's your main. All right, so it's just an area where you would put in the calls to the functions, all right? The main area, but that makes sense. That's actually makes a lot of sense to think that way. All right, so we're gonna have some data, right, for encryption and decryption. So let's say S, actually let's use the proper terminology. So it should be plain for plain text. So plain text is going to be what? This is, today is Tuesday, right? Now, remember, it's very important what you choose here as far as the characters, because the problem only talked about 26 letters, right? It only talked about 26 letters that we want to translate. So remember, you may want to add us a note here what the logic of the translation is. So what was it? If it's A, what was the equivalent number? 26. Very good, 26. If it's B, it's 25. And so on, right? So it keeps going. Then I'll do one more. If it's C, it is 24. So this is the logic, and we only set this for 26 letters. Do this for 26 letters. Now, is there a way that you could extend the logic of this code to numbers? Possibly, right? You just got to look at the ASCII table and see what works. Does that make sense, guys? Everyone with me? All right. So this is actually our algorithm that we're trying to implement, okay? And so we're doing this very simple one. We're not going to be doing any XOR operations today, but we will be looking at XOR operations on Thursday for the problem that you have to implement, okay? But this one is just a very basic substitution cipher, as I said, to practice Python. So today is Tuesday, and my name is John Smith, and put your name on here. If you choose to put a date or something like that, if it has numbers, just think that your program may or may not support that. So you got to really think about that one, okay? But it may not be as difficult as you think. And then obviously we want to have the cipher. So currently we don't have a cipher, but once you have written encrypt, you can take a string, encrypt it, print out the cipher, and then you'll have it, right? So currently I'm just going to write in here, this will be the cipher. Okay, so what you want to do is once your encrypt function works, you want to print out that result, to the terminal possibly, and then paste that in here so that you can use it for your decrypt function. Okay, so now, with encryption, it's pretty straightforward. Now you just go in and say, okay, cipher this will actually handle everything easily. So we make a call to encrypt, right? So we make a call to encrypt, and the input to it is what? Plain text, right? Plain text is the input to it. Got it? I believe I can make this a little bit bigger. Maybe not. There we go. Okay. A little bit bigger. Okay. Now we can do, so we have the cipher, and then the next step would be, so we're going to say decrypted cipher, right? So this is the output that we get. And to do that, we do decrypt and cipher, of course. Got it? Okay, I sometimes like to write things like this, just like, so there's more symmetry and it's easier to read. All right, and that's basically it. That's the bulk of the code that we are doing, okay? And then you can just print out your results. So for instance, here, you could do print cipher, right? And then here you would print decrypted cipher. Any questions so far? No questions, right? Pretty straightforward. All right, so now, obviously, we should probably start with, this code will run, it's just that it's going to give you 0. So it's a good point now to debug, right? So you want to do things like this so that you don't get a ton of errors later on. So we're just going to run Python. I think in the CVM, we have to say Python 3, I believe. Maybe not. Or is it an error? Oh, it takes, oh, okay. No arguments, right? So I forgot to do that. So I gave it arguments to the functions, right? And I forgot to include those. So I'm just going to go in here and say, this should be plain. And then this should be cipher. Got it? Any questions? All right, so I'm going to do Control X, Y, enter, clear. I'm going to repeat this again. And that's just a typo. So it should be this one, encrypted cipher. And there we go. See, our code is working perfectly nicely. All right, so now we have to just focus on our two functions, right? And we should be able to make some good progress. Okay, so we're going to make, because we're going to use the ASCII table, right? We're going to make use of two functions that are available in Python called ORD and CHR. All right, so those are the two functions that, given, let's say, the letter, they're going to give us the equivalent ASCII number, right? Or given the ASCII number, they're going to give us the equivalent ASCII letter, right? So that's the idea. So let's kind of motivate that one, see if we can't figure it out. So if you do Python like that, it just gives you the Python interpreter. It's like a command line thing in Python so that we can play with it. So let's say I have a letter, letter equals, and I'm going to choose the letter R, for instance. So I hit that, so I have letter now. And then if I do ORD letter, what does it give me? It gives me the number 114. You see that? Now we cannot use these numbers, right? We can't use the numbers given. We have to use the numbers that were specified by the problem. And the problem said specifically that it wants you to, if it's A, it should be 26. If it's B, it should be 25, and going down all the way to Z. Okay, now, if I have the number 114, I can create a variable number 114, right? See that? And I'm going to now make a call to the function CHR. So CHR number, and there you go. I get the letter back. Does that make sense? And this is the basic mechanism that we are going to use to try to solve this problem. Okay, this problem is straightforward, except for like it's not the logic itself of the encryption. It's like the other things that we have to do, right, to make this to work. Okay, so let's go ahead and start processing. So I'm going to exit out of this one, the interpreter. I'm going to go back to where we can just edit the file. Okay, so we're going to go into encrypt. Plain is our sentence. Okay, so what we want to do is we want to, first of all, not worry about uppercase or lowercase, because with uppercase and lowercase, we have different numbers in the ASCII table, right? If you look up that ASCII table that I made available on Brightspace. So to avoid that problem, let's just make everything lowercase, right? So how do you do that? Let's create a variable text, and then it's going to take plain, and we can make it lower. Okay, just like that. That makes it lower, basically. Any questions? Just double check this thing. Okay, so it's recording. I don't think it's complaining. I can see this thing getting green, right? So that means there's audio. All right. So back to the code. All right, so we've got this. It's always a good idea as you're writing these functions to kind of just run a little bit, right? So we want to print out text. So let's go ahead, Control X, Y, run the function. And today is Tuesday. My name is John Smith. So you can see now it's got the sentence there. And so it's printing it out, okay? So that's good, making good progress. Now, I'm going to go back to the code. You don't need to print all the time, just like comment it out and use it as you need to. So indentation, remember, should be 4 spaces here. So a very common mistake. All right, so now, what do we have to do? What's the next step, you think? To encrypt. Or let me put it this way. How would you approach encrypting at this point? If, okay, and do what?
If letter equals A, or like split it by character.
Okay, yeah, split it by character. Very good. Right? That's what we have to do. I just showed you how to go from a letter to a number to a letter. So we currently have a string of letters, which is like, you guys are familiar with arrays or something, right? So we have an array. You can do the length thing. That's a good approach also. So why not do that, right? So that's what I would suggest. So let's call this. Now, this is a variable length thing, right? So because you're writing different secrets and different things. So I would say plain length. The plain length, right? And let's get the length of the string. Okay, so I'm going to do, now in Python, this is something that you may not know, but there's a lot of functions. So you can just do something like this. Plain length, and so now that's something else that we can print. So let's go ahead and do that. Plain length, right? So once again, let's just run it. and it's 39, right? So the length of that sentence is 39, what? 39 letters probably, right? And so what do we want to do now? Since we know it's like an array of 39, right? We now want to index through them, right? In a type of a for loop or something along those lines. So let's go ahead and do that. So we can comment this out once again. We've got the length, and now we're going to create our for loop. So I'm going to say for I in range. This is a standard approach in Python. Notice the colon when you at the end of functions, if statements, or for loops. Okay. And then I'm saying here for I in range. Range just says from 0 to a maximum number. So in this case, we probably want to say plain length. Okay. Questions? Okay, no questions. Good. Very good. So now, all right, let's see if you, so now I want just one letter, right? Now, what do we use for, yeah, let's say letter. So 1, 2, 3, 4. Again, indentation, you just have to be consistent. So I'm going to use the variable name letter. And now from the string, I want from plain, I want to index every letter, right? So how would I do that, do you think? A dictionary? But you're already thinking of the encryption, I think. I just mean let's grab all the letters right now from the string and put them one at a time into this. Not letter, I, right? Yeah, but very good, yeah. So plain, square brackets, right? We index it, and then I. And that should give us every letter, right? Because we want to encrypt every single one. And notice this is sequential. It's going to have a pattern, right? So that would probably mean that it's not a good cipher already, based on what we discussed before, because if you do cryptanalytics, what's going to happen? You know, if you had a lot of text of this, certain numbers would appear more than others, right? Based on the letters that appear more than other letters in language itself. So if common letters are what? S, A, N, E, E, right? E is very common, exactly, very good. So it would appear more. So even though you wouldn't know, you would find a number that is more common than other numbers. And from there, you could infer, oh, that may be E. And that's the whole key to breaking this. Does that make sense? That's how you would do it. So it's insecure. Okay, but we're just practicing this one to kind of get familiar with Python. And then after that, we're going to next week, or sorry, Thursday, we're going to look at the XOR approach. All right. So we've got the letter. So now let's go ahead and print the letter. And it's going to print them down, right? If we did this right, print letter. So now let's go ahead and run this. And there you go, right? We even printed the spaces, right? So will spaces be an issue? That's a question, right? We have to think about that one. But you see that? So we've got the letters. Perfect. So now that I have the letters, let's comment this one out as well for now. Got the letter. Okay, so let's see. So what do you guys suggest we do? Got the letter.
If letter equals a number equals.
Ah, that's what you want to do, right? So and that's what you said with dictionary. I get your idea. Yeah, that would work. That would totally work. And that's a correct approach. It's not incorrect at all. But we're just going to take an even more fancy way of doing this just to make it more fun, right? So instead of that, I want you guys to do this through like one equation. Okay? So we're, And I try to crack an equation of how to arrive at the numbers. So basically what the equation should do is something like this. I'm even gonna write it here. I'm gonna say, how can I, yeah, code, that's a good word. Code, it's gonna be our function, and let's say, you know, cipher function, right? And basically what this does is it's going to take an input and it's going to give us the number. So that dictionary that you want to create, right, would be this function, but without hard coding all the entries, instead through an equation, okay? So I'm going to create a second function over here. And we're going to write the definition for that. So I'm going to say define function cipher colon, and then this will be what can we call this? ASCII. Let's call it ASCII val. Okay, that's a good, because that's what it is, the ASCII val. Okay, and then 1 2 3 4, just be consistent with that. Return 0 for now, all right, because we haven't defined it. But like you guys said, I mean, you already can solve this on your own by creating your dictionary, etc. Sure. It's just I kind of don't want you to do that, just to make it more interesting. But this function should return values such as this, with this pattern. Right? Any questions so far, guys? Nope. All right, good. So now let's go down here. So we set that if this is ASCII val. All right, so ASCII val. Now I need for a given letter the actual ASCII val. So we want to take advantage of that. I just showed you how to do that, right? And that was the function ORD. So ORD takes in letter, right? And then the input to this function will be the ASCII val. Got it? So let's print out here ASCII val, just so that we've already kind of seen this, but just to kind of corroborate. So I'm going to hit Control X, Y. Going to hit clear here. Right, and as you can see, it's printing numbers, right? It's printing the numbers. And already, it's not a very good cipher because there's definitely some kind of a pattern going on here. You see that it doesn't meet Claude Shannon's definition that you should not be able to tell anything about the message from the cipher. So if we look at this, let's do a little bit of cryptanalytics. So the sentence was what? Today is Tuesday. Today is Tuesday. And my name is John Smith. What's one number that's going to repeat a lot here, or the most? Or which letter in here is going to repeat the most, do you think? T or A? How many A's do we have? 3, okay. And there's 3 T's. So at the beginning we have a T, and then almost at the end we have a T, right? So that will be easier to spot. So let's do that. So the first number and the before the last will be the same. So the before to last is 116. Is the first one 116? It is. You see that? So not a good cipher because of that. Because you can start to, here you don't have a lot of text, right? But imagine if you did intercept a whole bunch of these texts, or if it's like a paragraph or a couple of pages, you'll start to spot patterns, and then you could break it. Okay, so it's not a good cipher. But again, we're just practicing a little bit. All right, so let's go ahead and try to wrap it up. Okay, so I'm going to hit this one over here. So I can comment out the print statement. And now what we want is we want to make it to this part. And we want to convert let's call it cipher code, right? So we want to take ASCII code, or ASCII val, sorry, which is a number, and convert it into that value, right? So ASCII val for the first one, so we need to crack this somehow, right? We need to know how to approach it. So what do we know? We know that we want A to be 26, correct? Yeah? Okay. So if we want A to be 26, then we could say ORD A, right? Just to see what it actually will be as an ASCII value. Okay. Oh, yeah. Sorry. Okay. 97. Okay, so take out our pencil here. So 97. And then we want it to be 26, right? That's 97. We want it to be 26. It's 97 right now. So minus 71. But will it work for all the letters? It won't work because it's going in reverse, right? So 97 minus 96 gives you 1. That's A, right? So B would be 25 that we want it to be. And will be what number?
98.
98. Okay. Minus 96 would be 2. Right? So then what's missing here to get our value? Because that's going to be 25. So if you have, so let's do ORD B, right? 98. Good. Okay. So we get 97A minus 96 gives us 1. We get B 98 minus the same 96 gives us 2. So it's going up, right? But we want A to be 26, B to be 25. What do you guys think? If we want 26 equal, right? We've got a 1. What do we need? Plus 25 gives you 26. Okay. We also have 25, right? That was what we want, but it was a 2. So this would be plus 24 by your plus 23. But it's not the same number, right? So what if, since we have 1 plus 2, we had 27 minus. 27 minus 1, 26. 27 minus 2, 25. You guys, I'm cheating. I'm looking at the answer here, so don't feel bad, right? So, but you see what I'm doing? So with that, what's the equation there that would give us this? And that would make it so it works for a simple answer. We got ASCII value minus 96, right? And that gave us for 97 minus 96, 1. For 98 minus 96, 2, right? And the sequence would continue. So that was 1, 2, 3, 4. But since we want the opposite, 27 minus. You guys see that? And then let's just test it out to see if it works, actually. So this should be the formula, right? So we got this nice little function here, right? And now we want to test it. So let's run a little example here. So we're going to do down here, what is it? Function cipher, right? Just to test it. So print. Oops. And let's comment out the rest just so that we only worry about this part for now. Comment that part. Comment this, comment out this part, comment out that part. Oops. Comment out this part, right? So now in here, we're going to say ORD of A, right? So what should this give us? 26, correct? Given the logic, everyone with me, guys? We're just testing out the function. So I'm going to do Control X, Y. All right, so if everything's correct, oh, sorry. So okay, right? So this one, I'm gonna run it, should give us A, right? No, sorry, 26. Nope. A is not defined. Oh, it's that same mistake. Sorry about that. It's not a variable, it is a string literal. Okay. All right, so try it again. Should give us 26. Nope. Oh, because I forgot to remove this thing. So now it should say cipher code. Right? Okay, so let's try it. Okay, one more time. Cross your fingers. 26. There we go. All right, good. So we'll do a few. But it should now work. It's going to give us what we want. And we don't, the dictionary was fine too, but this is just like a more elegant solution. So let's do B. So this should be 25. And actually what we can do, I think I can copy paste this. Go. So we're going to just do a few. Okay, let's just do a few. So B should be 25. C should be 24. And D should be 23. Right? All right, so 25 to 23. There we go. So it works perfectly. We can do this. All right, and that's it. Okay, so now let's go back to the code. Do nano. And get rid of these functions. So they were just there, kind of do some debugging. We're going to uncomment our functions, and we're getting very close to encrypted, right? Our message. But we've already established that it's not secure because there's patterns in there. So that's why we need like the XOR operations that we've been learning about, and we'll practice that on Thursday itself. All right, so now all of this is good. So let's go back to the encrypt function. Okay, so that works. So we're here basically. So now we've got basically the dictionary mapping that you guys were talking about, A to 26 and so on. So now we are going to get numbers 26 all the way down to letter Z. Now 26 has 2 digits. What about Z, or those lower letters? How many digits do you think they'll have in the number? One digit, right? So we're going to have a little bit of a problem that some have 2 digits, some have 1 digit. How are we going to handle that in this encryption? So probably the best thing to do is that every letter gets translated into 2 digits, right? It just makes it easier to encrypt and decrypt. The issue with that is then we're going to have, when it's 1 digit, we're going to have to add a padding, which in this case, 0 makes sense. So if it's 7, it'll become 07. If it's 4, it becomes 04. If it's 16, it stays at 16, okay? So that's the other trick that we have to do. So how do we do that? We are going to need to have some kind of a variable in here that's going to hold the cipher. Okay, so let's call that one, let's call it S code. We haven't used this letter, I don't think. All right, and initially S code is going to be blank, but we're going to concatenate. It's a string, basically, and we're going to concatenate into it our values. So here we're going to use an if statement. So I'm going to say if code. Now this code is an integer, by the way. So it's not a string anymore. It's an integer, so that way it can be evaluated as a number. So I'm going to say if code less than 10, right? It means it only has 1 digit, correct? Notice the if statement has a colon here. Okay, so this has a colon. So then we have indentation 1, 2, 3, 4. And so now we're going to accumulate on S code what? The 0 and the code, right? Perfect. Very good. Now, remember, code is an integer, but we're going to save this as a string. So we have to convert that integer into a string. So Python has this function called str for string. So we take code, it is now a string. Boom. But if it was a 7, it is just a 7, only it's a string as a 7. And then let's add the 0 as a string. So easily we can do that just by adding 2 single quotes and a 0. That should be a 0. A 0, make sure you don't type an O like I just did. And then to concatenate, you do this. That's it. Got it? Any questions on this one? And then we're just going to be concatenating the digits, the 2-digit encodings. And that's it. All right. Now, if it's not less than 10, then we use else colon 1, 2, 3, 4. Make sure they align. S code equals what?
Keep it blank.
Not blank, because S code is holding all the encoding. Make it code. Just code. But code is an integer. String code. Right. Yep. Very good. All right, and that's it. This is just the way I have my code, by the way, so it could be different. All right, so that's it. We're done. We've encrypted our message. So now we generated S code outside of the loop, right? So it means it lives outside of the loop. Once the encryption is done and we get to the end, boom, we just send S code back, and that's your cipher. All right, let's see if it worked. So we've done all of this, we've done all of that. Decrypt will just give 0. Let's not print a whole bunch of things anymore. So let me just make sure. We're not printing anything. All right, so yeah, so we should be fine. This should just give us the encrypted message. So today is Tuesday, and my name is John Smith, will be basically encrypted in using this substitution cipher approach in Python. So let's, if it works. Okay. Go ahead and run it. Okay. Nothing.
The first letter.
Yes. Very good catch. What am I missing? Plus equals, right? So let me very, very good catch. So S code. Yeah, that should do it, right? I wasn't accumulating, and I was only grabbing the first letter. Is that obvious for everyone, guys? The error? Okay, so let's try it now. Now it printed 19, I guess, which was probably the last. Was that the last letter? Let's try it again. Okay, 19 was apparently the last letter. Wasn't one no, but 116 was when we were looking at the ASCII codes, right? So this is different. Okay, so it should be correct. Okay. So look for an A, and A is supposed to be 26, right? So let's see if it works. So this is one letter, second letter, the fourth letter is an A. What was the string? Today. Today, right? So the fourth letter is A, and that's a 26. Got it? Any questions? That's it, right? So good. So we're done with this one. Yeah, that, great. Now, obviously, we need to decrypt it. Okay. So obviously, you could just use the variable cipher, right? And plug it in here. Okay. So that's basically plug it into decrypt. And we're going to go ahead and decrypt it now. So we just got to reverse everything. So keep in mind, as we work through problems this semester, we always kind of have to have these functions, right? Encrypt and decrypt. So now the reverse of it, or the mirror image, or whatever you want to call it. So let's go ahead and focus on decrypt now. And decrypt is just kind of the in reverse process. Now the only issue is, well, a couple of issues. One is that function, right, that we did here. Now you're going to have to change it maybe. So you guys will have to think about that one, right? We'll take some time to see if somebody can just solve it. We'll do it in class. I mean, it's not going to be a homework. All right, so let's see. How do we decrypt this? Any ideas? Remember, the problem we have is that we have 2 digits. Right? Now, is it always going to be an even number in length? No? Even if we have 13 letters, we'll have 26. Well, no. Or yes, maybe. So how do we proceed? Let me put it in another way. Every 2 numbers is a letter, right? Every 2 digits. So we have all the sequence of digits. The first 2 digits should be a letter. The next 2 digits should be a letter, and so on. How do we grab them? 2 at a time. In the previous example, we just had to grab 1 at a time. What do you guys think? So let's just start trying things. Oh, go ahead. You have an idea?
For that for loop, you could do
For loop.
I plus 1.
I plus 1. No. Okay. So what we need is probably some kind of a step size, maybe. So let's just start trying things out, right? So that's the best way to solve it. So for I in range, right? And we know it's in cipher, but we need to grab 2 at a time, like scoop 2 at a time. Okay, so for I in range, now we do need the length of it, I would say. So let's get the length of this thing. So let's say length cipher, right? Length cipher. And that should be length. This is just a string of cipher. So let's actually print that one out. Print length cipher. This one. Length cipher. Okay, I'm going to comment out this for loop because it's incomplete right now. All right, so let's just print that one out. $78, right? That should be the value that we have. So we need 0 and 1 to be one string. 0 and 1, 2 and 0, 1, 2, 3, 4, 5, maybe something like that. Right. So that's kind of what we want to play with. But we need it to do it that way, right? Because at least it's consistent. Okay, so then we've got the length. So for I in range, length cipher, and let's say from 0, so we can say that. So now the question is, if we do this, is that a step size, right? So then let's print out I just to see what happens. 1, 2, 3, 4, and let's see if we can play with this. Let's see if we can play with this value once we have it. So let's do that. Okay, what's it giving us?
Increments of 2.
Increments of 2. So it gives us 0 to. So it gives us 0 to 1. It gives us the start, right? 0, 1, 2, 3, 4, 5. Yeah, so it's giving us the start, right? So then we may use this to get what we need. Because it would always be that value plus 1, correct? Do you guys see that? All right. So we know that. Everyone with me, guys? Any questions so far? So we've got a value, and we know that we need two indices, that value and plus one that to get the segment. So let's try it. So it's in cipher. So we're going to say print cipher I concatenate cipher I plus one. Do you guys see that? Do you think this will give us the digits maybe? All right, let's try it. It's the only way that we can find out. Let's get rid of the print I. We know that was working. I'm going to hit a clear here. So that 0 is just, it's fine. So we know that the fourth one was 26, right? Do you guys remember that? We established that the fourth one was 26. So what do you think? Does this approach work or no? It does, right? Cool. All right, so we've got it, right? We got it. So now, because we've got zeros in here, I think we don't actually have to remove the 0. We just have to treat it as an integer and we're good. And so now we can probably run it through the equation in another order, right? And then we'll have the values that we need to run through the ASCII table. Okay, so now let's go ahead. So I'm going to hit clear. Oops, clear. I'm going to go into the script and I've got my numbers. So what I need now is I need to just hold these values in a variable instead of printing it out. We don't want to print it out anymore. So we just want to go in here. What we want to call this, let's call it the code. Okay, and it's going to be, now we want to convert this to integer, so we can do that directly here, right? So that can be done directly. And then all we have to do is do cipher I plus cipher. I mean, remember that plus is actually a concatenation of strings. So both of these are going to be strings, I plus 1. But this string that becomes the 2 digits now runs through an integer function, and it is now an integer. So that we can do a computation on it. Got it? Any questions? No questions? All right. So now, since we have the code in there, we can create another function like this one. So I'm going to say here, define func. Since one was called cipher, this one then can be plain, just to kind of have it make sense. This is actually a code val, right? Code val, colon, 1, 2, 3, 4. And basically, what are we doing here? Here we have a 26, right? And we want the letter back. So we need to do the reverse. 26A. We're going in that direction now. 25B, correct? 25B. All right, so we need to now, we're going to have a return, obviously. So 1, 2, 3, 4. Return. All right, we're going to call this one to be consistent. 1, 2, 3, 4. Plain code. Plain code. And we need to figure this one out. Okay, now func plain should be invoked here. Gets invoked here, and it's going to give us let's just call it. It's an ASCII value, right? So this will be an ASCII value, I think. So we can call it ASCII val. What goes in here? Oh, very good. All right, good. So ASCII, so that's nice and everything. Now, here comes the tricky part. Let's take a few minutes. Let's see if you guys, I can cheat. I have the formula right here in front of me. Let's see if any of you can figure out the reverse of this one. Think about it for a sec. I mean, it's kind of like that one, right? And you know what the numbers should be. So what do you think? Assume it's already an integer. A in the ASCII table should be what? That's what you need to think about, right? B in the ASCII table should be what? What is it now? So what do you need to do to the equation to get those values? All right, I'll pause the video for a sec. So it's not, there's no delay there.